Mixture problems where you're in a lab and mixing up solutions are common fare in algebra books. So let's take a look at some solution methods. So whenever I do these kinds of problems, I have to draw a picture. And I draw a picture that looks like beakers, and my beakers look like rectangles. So here we go. Let's read that top problem and see what we want to do. So we have a mixture that is 3% salt. No, we want a mixture that is 3% salt. We have 70 milliliters of a mix that is 2% salt and an unlimited amount of a mix that is 5% salt. And of course, that's amount. How much of the 5% mix should we add to get the 3% solution? All right. So my pictures look like this. I draw rectangles, and in the first one I put what we have to start with. So we have 70 milliliters. So in each rectangle, I'm going to put a volume, so an amount, and also a percent. And I want the percents to be the same in each box, so let's make sure. So I have 70 milliliters, and I want 2% salt. So my percents are the amount of salt. And what we're going to do is we are going to add some 5% solution. So we're going to add some 5% solution. So I know that next thing has a 5%, but I don't know how much. In fact, that is the unknown. How much of that 5% should we add? So that's going to be our x, the amount of the 5% solution. So that'll be an x. When we end, we know we want it to be 3% solution. And how much of that do we need? Or how much of that will we have? Well, we'll have 70 that we started with plus x, however much we have to add in of the 5%. That's going to be the total volume when we're done. And then from this picture, I write my equation, which is essentially how much salt we have at each stage. So it's the percent of salt times how much volume we have. And remember, percents go in equations as decimals, so 0.02 times 70 plus 0.05 times x equals 0.03 times, that's a binomial, so it goes in parentheses, so we distribute. And here's an equation that we have to solve. It looks linear. I also have those decimals with hundredths places, and so I'm going to multiply both sides of this equation by 100 just to make it nicer. So what that'll do on the left-hand side is, right, it distributes to this term and this term, and so it'll just make those decimals go away. So I'll have 2 times 70 plus 5 times x equals 3 times 70 plus x. And I know you guys are great at solving those, so go ahead and rewrite it without parentheses. You don't need to watch me do this. You should be doing it on your own. Subtract 3x from both sides to get the x terms together. Subtract 140 from both sides to get the constant terms together. And then finish by dividing both sides by 3 to get x all by itself. And since I started in milliliters, everybody is in milliliters, so we'll go ahead and be good and put our units on. So we need to add 35 milliliters of a 5% solution to the 2% solution that we had in order to get to a 3% solution that would be, right, 105 milliliters altogether. So the second question kind of has a lot of the same things, but this time we're not going to add in a 5%. What we're going to do is we're going to add just straight salt. So I'm going to have to squeeze this in. So I start with the same 2% and 70 milliliters. But this time when we add, again, I don't know how much we're going to add, how much pure salt, that's our unknown, but the percent for pure salt is 100%. And then we'll end at that 3%. And again, the amount would be 70 plus x. So the equation, again, is percent times the amount, percent times the amount, percent times the amount, and carry these signs. The words in the problem will tell you if you're going to have a plus, and then after the equals, that's how you want to end up. Sometimes you'll know the exact amount you want to end with, and so you'll have more unknowns over on the left-hand side. So let's look at that equation, 0.02x, 0.02 times 70 plus 1 100% as a decimal is just 1, so 1 times x equals 0.03 times 70 plus x. Hey, we've seen that before. Let's go ahead and multiply through by 100 to make those decimals in front go away. So 2 times 70 plus, don't forget to multiply that middle term, write that second term on the left by 100, plus 100x equals 3 times 70 plus x. You see I'm running out of room, so I'm going to start squishing. Here we go. 140 plus 100x equals 210 plus 3x. X's together, so I'm going to get 97x equals 70 when I bring the 140 across. And then do a division to end. So x is 70 over 97. Go ahead and grab your calculators and punch those in. And my calculator tells me 0.7216 and a bunch of other things. So my chemists, forgive me for my significant digits, I'm really bad at them, but I will round that to 0.72 milliliters. So that's not a whole lot to take, right? If we're looking at 70 to start with, we're going to add in less than 1 to bring that concentration up from 2% to 3%.